of the most commonly used temperature sensing devices, the thermocouple. If you're deciding what instruments are going to be placed on a machine or into a process, the more information you have, the better. Having said all that, let's start our walk down thermocouple lane. A thermocouple is an extremely simple device used to measure temperature. Thermocouples tend to be inexpensive, durable, and can be fabricated into a variety of shapes and sizes. A thermocouple is made up of two dissimilar metal wires. Dissimilar is just a fancy way of saying different, but for some unknown reason, that word tends to be used most of the time when discussing thermocouples. In any case, the metal wires are connected together in only one place, typically the tip of the thermocouple. Lots of manufacturers call that junction by different names: hot junction, measurement junction, sensing point, or sensing junction. Those terms all refer to the same thing, the place where the dissimilar metals are joined that will measure the temperature. The wires at the opposite end from the sensing junction are then left available to connect to some kind of measuring instrument like a temperature transmitter, a simple electronic display unit, or even directly to a PLC thermocouple input card. The wiring terminals on the measuring instrument are most often called the cold junction, while the hot junction refers to the tip of the thermocouple that will be exposed to the heat source of interest. The cold junction refers to the thermocouple wire connections that happen right at the measuring instrument, which typically is not exposed to the same thermal energy. All thermocouples work the same way. They generate a small voltage when they are exposed to heat. If you're interested in the detailed physics of the way this works, you can research topics like the thermoelectric effect or the Seebeck effect. But to put things in simpler terms, when you heat up a piece of metal, the electrons in the metal want to move around more and will tend to move through the metal away from the heat. Because electrons are negatively charged, the colder end of the piece of metal will have a negative charge compared to the hotter end. A thermocouple works based on the movement of the electrons in its metal wires due to the heat difference between the hot and cold junctions. If the two wires of the thermocouple were made up of the same type of metal, electrons in both wires would move away from the heat at roughly the same rate, so you couldn't really measure the difference in the charge of the two wires. But if you recall, thermocouples are made up of two different types of metal wire, and those wires are connected together only at the hot junction, the sensing end of the thermocouple. The different metals in those wires, or more accurately, the electrons in those different metal wires, react differently to heat. When exposed to heat, the electrons from one of the wires will want to move around at a certain rate. The electrons from the other wire will want to move around at a different rate. The wire that has the electrons that move more ends up being more negatively charged at the cold junction, and will therefore be called the negative wire lead. The wire with the slower electrons won't build up as much of a charge, so it's called the positive wire lead. The difference in charge between the positive and negative wire leads can be measured and used to calculate the heat at the hot junction. This is the basic principle of how a thermocouple works. So let's look at this more closely at a specific thermocouple to make sure we've got it. Let's look closely at a Type K thermocouple. A Type K thermocouple is probably the most commonly used thermocouple in industrial applications because it responds predictably across a very wide range of temperatures, say around -330 degrees Fahrenheit to around +2,460 degrees Fahrenheit. The exact temperature ranges will change a bit based on how the manufacturer builds the body of the probe and the insulating materials used, but with that wide range, you can see why it can handle almost any application. Type K thermocouples are made from the metal alloys chromel and alumel. As we heat the wires, you will notice that the electrons in the chromel wire don't move around as much as the electrons in the alumel wire. Over a very short period of time, you can see the alumel wire has more electrons collecting at the cold junction, the cooler end, which means the Alumel wire will have a negative charge compared to the Chromel wire. This difference in charge, also called a voltage, can be measured. The more heat you apply to the metal wires, the more the electrons want to move around, and the more they move away from the heat. With the two different types of metal wire, the difference in the voltage will increase and decrease with changes in heat at the sensing point. The thermocouple voltages are very small. The actual change in voltage per degree Celsius is minuscule. For example, for a type K, the change is about 41 microvolts per degree Celsius. Also, interestingly, all thermocouple voltages are 0 millivolts at 0 degrees Celsius. Because the thermocouple manufacturers carefully select the metal alloys when they build the thermocouples, anyone can convert those voltages into temperatures using standard calculations. In fact, most manufacturers will provide some voltage to temperature charts so that you can get a good idea of the temperature difference between the hot and cold junctions. So hopefully you've enjoyed your walk through the world of thermocouples. While the science of how electrons move through metal can seem complex to the average person, taking advantage of simply connecting two different metal wires together to make a temperature measurement is pretty straightforward and inexpensive. There are other types of temperature sensors that can be used to solve installation challenges, such as an RTD, but that's for another video. If you haven't already seen the RealPARS video on temperature sensors, you might want to give that a look. While this video can stand by itself and get you up to speed on everything you need to know about thermocouples, the other video will give you some good general information on several different types of temperature sensors. You can find the link to this video in the description. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.